The next few slides are about defining indexes. Create indexes on columns to speed up queries, when the column is queried frequently. Indexes provide faster access to data for operations that return a small portion of a named Windows events, or a table's rows. One can create an index on any column. But, if the column is not used in any of the queries, creating an index on the column does not increase performance, and the index takes up resources unnecessarily. Only named window and tables can be indexed by create index. However, the compiler still performs query planning, and the runtime builds indexes for queries that don't use named windows or tables. The compiler performs query planning for the following types of queries. The compiler performs query planning for joins. Query planning for joins is regardless of whether the join joins a named window or table. The compiler performs query planning for subqueries. Query planning for subqueries is regardless of whether the subquery queries a named window or table. The compiler performs query planning for on-action statements, such as on-merge and on-delete. The compiler performs query planning for fire and forget queries. For query planning, the compiler considers the following. The compiler considers the where clause and the having clause, if provided. The compiler considers, for subqueries, additionally to the subqueries where clause, the in clause, if any. The compiler considers, for outer joins, the on clause. The compiler considers whether there are unique data windows. The compiler considers query planning hints provided by the @hint annotation. The compiler determines whether to use an existing predefined index, as defined by create index. The compiler knows about the indexes from the compiler path. If no suitable predefined index can be found, the compiler may instruct the runtime to build a new index. Turn on query plan logging to receive compiler information about predefined existing indexes that are used by the query, or indexes that the runtime builds for the query. This slide introduces the create index keywords. The syntax is create. Optionally, the unique keyword index. Index name. On. Named window or table name. Parenthesis. Field name. Optionally, the hash, or the B-tree, or an index type. Optionally, additional field names and index type keywords. The index name provides a name for the index. The named window or table name is the named window or table to be indexed. The field name is, for named windows, an event property name. And the field name is, for tables, the column name, provided the column is not aggregation type. The optional hash and B-tree keywords define the index type. For spatial indexes, provide the name of the spatial index. There can be multiple field names and a mix of index types. The default index type is hash. The hash index is an index using hash code and equality semantics. The compiler's query planner uses a hash index when the where clause has any of these. An equals, an in or a not in clause. A hash index can have multiple fields. A hash index can be unique, disallowing multiple rows with the same index value. For tables, the primary key column is implicitly a unique hash index. An example with a table and two hash indexes is here. The example defines a table that is keyed by account ID and a sub-ID. Create table account, sub-account, table. parenthesis account ID string primary key, comma. Sub ID string primary key. Create index account, subaccount, index. On account, subaccount, table. Parenthesis account ID. This defines two hash indexes. A unique hash index on the combination of account ID and sub ID, since the table declares the two columns as primary keys. And a non-unique hash index on the account ID. This example fire and forget query would look up on the index account subaccount index since it has an equals for account ID. Select from account, subaccount, table. Where account ID equals quotes A. The B-tree index is a sorted index. The B-tree index indexes any comparable type. A numeric type, string type or a type that implements the java.lang.comparable interface. When the where clause has a relational operator, less than or equals, greater than or equals, or a between keyword or an in range, the query planner uses a B-tree index. A B-tree index can have only one field. A B-tree index cannot be declared unique. This slide defines an example sorted index. First, it defines a named window to hold the last 10 minutes of withdrawal events. Create window large withdrawals. At time parenthesis 10 minutes. As withdrawal. The next query populates the named window with large withdrawals. Insert into large withdrawals. Select star from withdrawal. Parenthesis amount greater 400. Next, the example creates an index on the amount event property. Create index amount index. On large withdrawals. Parenthesis amount B-tree. This example fire and forget query would look up on the index amount index, since it is a between range selection on the amount property. Select star from large withdrawals. Where amount between 400 and 450. The following slides discuss fire and forget queries. Fire and forget queries return immediate results upon completion and execute in a request-response style. Fire and forget queries are not continues, they do not allow listeners, and fire and forget queries are typically discarded after execution. The programming interface for executing fire and forget queries is discussed in the Programming Interfaces section. We provide sample fire and forget queries here without concern for how to compile, parameterize and execute them. Fire and forget queries must have named windows or tables in the from clause. Except, they allow selecting directly from a relational database with SQL, without using the JDBC API. A fire and forget query can select from named windows and tables, including joins. Insert into a named window or a table. A single query can insert multiple rows. Update events of a named window or rows of a table, see updating named windows and tables among the prior slides. Delete from the named window or table. Fire and forget queries allow only one query at a time, but can be repeatedly parameterized and executed. Fire and forget queries do not have a semicolon at the end of the query to separate queries. This slide provides some example fire and forget queries. First, the examples define a named window or table. The example has the @public annotation so that the named window has public visibility. @public create window user session window. @time parenthesis 10 minutes. As parenthesis. User ID string. Comma status flag string. Note, the above is not a fire and forget query. The create window or create table cannot be used in a fire and forget query. Please consult the Programming Interfaces section for how to set up a compiler path for fire and forget queries. Example fire and forget queries are shown next. These queries are only valid as fire and forget queries and cannot be used in an EPL module. The first query returns the number of events in the user session window. Select count stars current count from user session window. The next query inserts an event. Insert into user session window. Parenthesis user id comma status flag. Select quote 001 as user ID. Comma quote inactive as status flag. The next query updates events. Update user session window. Set status flag equals quote active. Where user ID equals quote 001. The last query deletes events. Delete from user session window. Where user ID equals quote 001. Named windows and tables can be used with what we discussed so far, including patterns, match recognize, variant event types.